All right, so we are going to work practice problem number 8. Review problems. Number 8, prove if A is rational, then A plus square root of 2 is irrational. We may assume square root of 2 is irrational. So our game plan is proof by contradiction, right? Here's our Q. Oops. Other Q. Here's our P. This is Q. So we're going to assume the negation that there is a number A that's rational and A plus square root of 2 is rational. Are you good with that part? Okay, so do we need to talk about actually writing the negation of an if-then? Would that be helpful, Nick? You're the one that asked the question.
Sorry, I think my microphone stopped working. Can you hear me?
I can.
Yes, I do understand the P and not Q.
Okay, so I'll just, yeah, so let's go ahead and just write the negation. There is a rational number A and A plus square root of 2 is rational. All right, great. So that'll be our hypothesis, and we wish to find a contradiction. So it is proof by contradiction. So assume that A is rational and A plus square root of 2 is rational. It's going to give us a couple of equations. We wish to show a contradiction occurs. And the contradiction is going to be, of course, that square root of 2 is going to wind up being rational. But we don't have to, if you don't know that at this stage, just understand that is always the game when it's a problem that involves some rational numbers and some irrational numbers, and we're using proof by contradiction. The contradiction is always going to be that whatever is irrational winds up being rational. Okay. So by definition of rational, A is equal to, well, I'm going to use X over Y. Kind of got things flipped, but that's okay, where X and Y are integers, right? And Y is not 0. And, well, we've also assumed A plus square root of 2 is rational. Are you with me?
Yep.
So we're going to set up an equation for that. A plus square root of 2 equals, I don't know, maybe S over a T with a tail so it doesn't look like a plus sign, where S and T are integers and T is not 0. Okay, so we wish to show square root of 2 is rational to contradict the fact it is irrational. It's known. Because we proved that, didn't we? So, basically we're going to have to solve for square root of 2. So we got to somehow introduce an equation where we can solve for square root of 2. Does that make sense?
Yes.
So what I do generally, there are several ways to do it. But I look at the expressions, that are equal to a rational number, and I just take the bigger one that's got everything in it. It's got the a in it, but it's got the other stuff, which in this case is just square root of 2. And I set it equal to each other because that's a tautology that's always true. A plus square root of 2 equals a plus square root of 2 is a perfectly safe equation. I mean, that's true in any world. But, I'm going to just realize kind of what's going on here. I've got these nice equations that I want to use. And then we'll also use all this good stuff too. But right now, I'm actually just thinking about where I'm going to substitute. So I know I'm going to be solving for square root of 2. So, I mean, you could put in for this whole thing is S over T, or you could put S over T in for this. It doesn't matter. In fact, you know what? I'll do it differently than I did the example in class. This is going to be S over T. That's why I'm putting square brackets around it, just to kind of point to the fact I'm going to use, right, this proof money, right? And then we're also going to substitute in for A, because we want to use that bit of proof money too. So this is just supposed to kind of point you to up here. So what is A plus square root of 2? What can we put in for that?
That's just S over T.
It certainly is. So let's just put in S over T for that. Over here, that's equal to, and now what should we write?
X over Y plus square root of 2.
Exactly. So now we're going to solve for square root of 2. I'll just subtract X over Y from both sides. So it looks like square root of 2, it looks like that. Now I'm just going to, move everything around because I like to read left to right. Square root of 2 is equal to, and now what's our common denominator going to look like?
TY.
It sure is. Nice. And what's our numerator going to look like then?
S minus X. Is that?
No, this is where you got to realize the S is over T right now, okay? But we want to have it over T times Y. So we have to multiply S times Y. Think about it. I'll show you what's really going on. So we have S over T, right? Now we're allowed to multiply that by 1. That's always legal. You can always multiply anything by 1. But there's a very particular form of 1 that we're going to use to help us so that we can put the S over the TY. Namely, if we multiply it by Y over Y, which is just one of the gazillion ways we can write 1. See what I mean? So we haven't changed the value of S over T. We've just multiplied S over T times Y over Y, or 1. Does that make sense?
Yes.
That's the algebra for the numerator. So if we're looking at the X over Y, right? We can multiply that times 1, and it's still equal to X over Y. What is the form of 1 that we're going to multiply X over Y times so that we can get the X over a TY?
T over T.
Perfect. Nicely done. And there's a minus here, so we're going to keep the minus. And that is part 1 of the definition of rational. We have a numerator over a denominator, right? So we've got it written as a quotient. But now we're going to address, the fact that the numerator and denominator have to be integers. Well, they will be, right? What is it? Products and differences of integers are integers, products of integers are integers. And then we'll make sure to address the fact that ty is not equal to 0 because we know y is not 0 and t is not 0. And the ZPP gives us this result, right? So we just crank out, the remainder of the proof. Here we go. Since S, T, X, and Y are in Z, and what, products and differences, we could write it that way, of integers are integers, or you can say closure of Z under multiplication and subtraction. Products and differences of integers are integers. We see, I'll say M equals SY minus XT is NZ. Make sure to say it's NZ. I've noticed people are being so good and writing all this great stuff, and then they forget to say it's actually NZ. And I'll call the denominator N equals TY's NZ. So that's part 2 of the definition of rational done, right? Numerator and denominator integers. Finally, since T is not equal to 0 and Y is not equal to 0, the ZPP, zero product property, says N equals TY is not equal to 0. So that's part 3. So this means square root of 2 is rational, which contradicts the known fact, or the fact that square root of 2 is known to be irrational. And if you want to write a closing sentence, it's not required, but so I'll put a little curly wavy line under it, but oh gosh, so sorry. That was an accident. You need to do that. So if A is rational, then A plus square root of 2 is irrational. So again, this last sentence, it's nice. It's kind of like the cherry on top after all that work, but technically, you know, it is optional. What is not optional is the contradiction. This contradiction is a must. You must state the contradiction. Holy cow. That's like the worst writing I've ever seen. It's Halloween writing. This is my Halloween font. All right. Did that help? Do
Yes, thank you.
you want me to give you one more to work on later, Nick?
Sure.
So we'll call this problem number 8 prime, due later. Prove. I'm going to change things around a little bit. If X is rational, then X plus 5 square root of 2 is irrational. So it's just going to require like one more step of algebra, but it's kind of like eating your vegetables. You should still be able to solve for square root of 2. Like you'll have a 5 here and a 5 here, right? So you'll have a 5 times square root of 2. So at this stage where you're here, there'll be a 5 here. To clear that, just divide both sides by 5 and it'll put a 5 down here. That's the only difference. Does that make sense?
Yep. Thank you.
You're welcome. Other questions? Would anybody like? Well, actually, you know what? It's 7:52. I've been going. I need a little break, so I'm going to meet you back here in 8 minutes or so for office hours. Is that okay? Of course it is. Let me stop recording.